When you fabricate often for custom car audio, it is advantageous to have multiple different router stations. This is because the woodworking router is a versatile tool with its ability to use different router bits to accomplish different tasks, but changing out the router bits themselves takes time. In custom car audio, you virtually always want to have a flush trim bit loaded up in one of these stations. In particular, I like the 1/4" spiral flush trim bit as it allows us to not only copy templates and profiles, but also create an opposite male or female shape, as it is capable of cutting on both sides of the bit when you don't rough cut. Now, shaping bits like roundover bits and chamfer bits are also a must use. You commonly need to have these loaded into the router, but over the years, more and more, I've found that there's another router bit that I like to commonly leave loaded up, ready to go. And it's because this bit allows me to do quick resizing. It looks like it's just a normal flush trim bit, but it's not. So what is that bit? What does the resizing process look like? And why do we need to resize things throughout a custom car audio build? That, my friends, is coming up. Before we get into it, a quick thank you to our sponsor for this episode, New Concepts. If you're building a car audio project, you of course need wire and power distribution parts, and my go-to source is New Concepts. Their Colossus Flex power cable is ultra flexible for easy routing throughout an install. And their several different basic fuse and distribution blocks are simple and effective. They are reliable and have a great value. Be sure to check them out for your next car audio build. You guys can learn more at the links down in the video description. The second bit that I've found more and more handy to leave living in my second router of my 3 router stations here is this 1/32" rabbeting bit. In our case for custom car audio, what a rabbeting bit is basically a bit that is going to ride against a profile much like a flush trim bit, but it's going to transfer that profile with an offset. This is a really big rabbeting bit. This is a 1 1/8" rabbeting bit, meaning the edge of this bearing here to the edge of the cutting flute is 1 1/8". But there are a variety of different rabbeting bits that we can use. In this case, this kit here has all the same bearing size. It's the cutting flutes that change. But you could also go with a kit like this, where the rabbeting bit stays the same size, but it's the bearings themselves that change, which allows you to change that offset. Regardless, the one that I found very handy to always have loaded up is this 1/32" rabbeting bit, which is right here. So even though it's hard to see, the edge of that cutting flute to the edge of this bearing right here is 1/32". So let's go through the typical resizing process here. Now, as an example on this application, let's say that we've cut a hole for a subwoofer and the hole isn't quite large enough. We need to increase its size. Obviously, you can't add wood material, you can only remove it. So if you are going to use this process, make sure that the template that you pick is undersized based on the size of the hole that you ultimately need. To bring you up to speed really quick, just in case you're not familiar with using templates, we typically use them along with a flush trim bit in order to perfectly match the profile. So in this case here, we have a circle template for a subwoofer cutout hole. I wanted to match that profile, and I'm using a 1/4" spiral flush trim bit. This has bearings on the top. The bearings ride against the template and perfectly transfer that cut profile to the surface down below. Now, every speaker and subwoofer out there has a slightly different cutout size, and it is advantageous to match our cutout perfectly to our subwoofer or speaker. So that's why we need to do this process. And right now, I've already flush trimmed to this profile. To do our rabbeting bit resize process is going to require that we flip this piece over, and we just don't need this template in place anymore anyhow. So when you are doing this process, make sure that your template is removed and out of the way. So what I'm going to do is I'm going to lower this so that it's about a little over half of the height of this board. This isn't an exact science, it just needs to be slightly over the halfway point, which I've adjusted here. So I can lock this in place, and I'm going to make a cutting pass, and obviously what this is going to do is increase the diameter of this hole a 1/32 of an inch on each side, or 1/16 inch total diameter. With that cutting pass ran, this top surface here stays the same because it's just riding against the bearing, but the bottom has now been cut to that larger diameter. So now if we go to that larger diameter side, we can take a subwoofer and we can see, have we made this large enough yet? No, we haven't. We still need to go a little bit larger. So back to where we were previously with our cutting pass, we want to make sure that we flip this over so that we're again removing material. And now our bearing is going to ride against that larger surface that we just cut. Now this may seem like a lot of work based upon the time it's taken me to explain it to you guys, but realistically this is a really fast process to make that cutting pass, flip the board over, and check our size as needed. In fact, if we needed, knowing that we add 1/16 of an inch of diameter to each cutting pass, we could simply just do the math, and rather than needing to check every time, we could know exactly how many flips and passes we need to make to hit our final target dimension. Once we do hit our final dimension, we are going to have a step left over here that we need to match to our final dimension. And we just do that simply using our flush trim bit, which is always loaded in one of our other router stations, commonly in the car audio install bay. In this case here, the bearing is going to ride against our final dimension there, and we're going to cut and remove that excess step material. So doing this process allows us to quickly and easily resize a cut as needed. And obviously our example here was for a subwoofer enclosure. You could also do this for a speaker cutout, a speaker ring, but there are lots of other applications as well. Now you may be wondering, where can I get this bit? When I teamed up with our other show sponsor, Mobile Solutions, and designed this, the CarAudioFabrication material gap gauge, I wanted to make sure that this bit was included with it because it's so handy to have. So you can get it as part of this kit, or you can also buy it from Mobile Solutions a la carte. A big thanks to them for also being a sponsor of the channel, and you can see those links down in the video description as well. So throughout the fabrication process of a build, especially when I'm needing to make different pieces fit together after being wrapped in upholstery materials, I find that I'm constantly needing to remove material. This is often needed for material gaps, as we need to intentionally have a gap between surfaces when we know that they're going to have upholstery material on them when they are in their final form. And those upholstery materials, of course, have a thickness. When we account for that thickness, even if it might be really small, we do get a much better final fitment. More and more, I've found that having a small 1/32 inch rabbeting bit on hand ready to go is handy for doing a quick gap adjustment and resize on different holes throughout a project. As an example, let's talk about a subwoofer. Let's say it's a 12-inch subwoofer. One 12-inch subwoofer is going to have a totally different cutout size than another model 12-inch subwoofer. Rather than trying to use one template for all subwoofers that might result in a loose, sloppy fit, I'd rather keep templates on hand that are intentionally a little bit small and allow me to quickly dial in the cutout size with the rabbet bit. Now you might be wondering, what about a router circle cutting jig? You know, the kind where you attach it to the router and then you turn on the router after plunging down into the material and spin it around. That process works great, but I've personally found in terms of efficiency, I'm a lot faster just by using my already set up table mounted router that's behind me here. I don't have to get out the handheld router. I don't have to attach additional dust collection and run that over, which inevitably ends up kind of getting in the way. It's a lot easier and more efficient for me to just use the router table. That's my opinion on the topic though. I'd love to hear your thoughts as well. Don't forget, for your next car audio project, be sure to check out our show sponsor New Concepts with their ultra flexible wire and their easy to install and use power distribution parts. You can learn more about them at the links down in the video description. A big thanks to them for making these videos possible, along with Jerry and the rest of the Patreon membership team. Thank you guys for tuning in and watching.